Yeah, so guys, we are going to demonstrate the first part, which is class file and anonymous class issues, and how Lambda deals with that. So we have this class e-wallet. It implements send interface. This is how send looks like. Then we have a test class main. So I'm just going to compile this class as is for now. Java c.main and c. So as you can see, we have 3 class files generated. 1, 2, 3 for each one of them. If we were to generate another file, we can call it bank transfer, maybe .java, and then it implements, and we make it implement send. Obviously we have to override the method, so we can say from +2 for now. This is the implementation we have. So if we come here, say bank transfer equals to new bank transfer, and execute this code, we are going to have another class file generated, bank transfer.class file. This is one issue. You can even have situation whereby you have anonymous classes. So let's see how Java will handle the issue of anonymous classes. I'm just create it on the fly. I'm just going to create it on the fly. So I have to provide implementation for the abstract method in here. So if I run this class, observe how Java is going to create a class file for this particular anonymous class here. See, it says main $1. You can just imagine if you have maybe a couple of them. I'm just gonna create as many as I can, and then I run the code again. See how many of these class files are generated. And all of these class files will need to be loaded into memory. An object is created for each one of them. That object needs to be garbage collected. So you see already you see performance problem there. Class loading, the footprint of this object that will be residing in memory, and the garbage collector having to remove each single one of them. So this is what problem that we are having, and we are going to see how lambdas actually comes to our rescue. So for now, what I'm going to do, I'm going to delete all these class files. I'm going to delete. I'm just going to be left with, I'm even going to delete the implementations of this interface. I'm just going to be left with main and send. So I want to create an implementation for send. That's the goal. And I want to give it here. So what I can do with lambdas, I can say send e-wallet equals to. So what we need to do, we need to check our interface, how many parameters, the method that we are looking at. It has, first of all, before I even proceed, for you to use lambdas, your interface must be a functional interface. In fact, to even enforce that behavior, what we do, we say at functional interface. So you want to make sure that this is a functional interface. So if I duplicate this code, so for now, before I even do that, let me run this code. Okay, I'm gonna do this just to ensure that this code runs after we edit that annotation. Everything is fine. So I can even run send itself. Everything is fine. Okay, so now if we are saying a function is a functional interface, it means that it only has one abstract method. So if we add two or more methods here, maybe let's say we can say withdraw from, just from account. We see now we have a problem, unless if we put a cursor here, it says invalid functional interface. Send is not a functional interface because now it has more than one abstract method. So you can have private method, now it's a functional interface, or you can have default method, or you can have static method in an interface. But the fact is it must only consist of one abstract method. That is the first thing. So having said that, implementing using a lambda, we see that if our functional interface has one abstract method that takes two inputs and returns nothing. So you have many ways to do this. You can decide to have it like this, in which case here you have to say, you have to provide the parameters. So we have two parameters of which both of them are strings. So you can say from, you can say to. You don't need to provide the type because the type will be inferred from the definition in the functional interface. As you can see here, we don't provide type for these two parameters. And what we can do now, we can say cout from plus 2, and then that's it. And then let's see what happens if we run class main. So what I'm gonna do, I'm gonna delete them again so that you are able to follow what's happening. If I run this code, you see we only have this generated. Let me save it again. If I run main, obviously I'm gonna delete, I ran the wrong one. Okay, if I run main.java, we see that only two of them are generated, and yet we have the implementation here, and we can even invoke this implementation. We can say e-wallet.send. What are we sending? From BSG to motifs. We execute and then we run this code main. You see BSG motifs because that's the implementation we are having here. Or you can just say printf and then provided parameters, and then here just those parameters. So CPSG motifs. So as you can see, actually here I wanted to make it a new line, sorry. As you can see, we didn't get more class files in here, and yet we're able to do the work that we want to do, which actually means you don't have performance problem when you are running an application. You don't have many class files to load, and the memory footprint and all things associated to those class files and anonymous classes. So another convention you can use here, you can specify the types for this, but if you specify the types, you must specify for the second one as well, and it should work. If you put the incorrect type here, it won't work because your functional interface doesn't have string in that order parameters. That's one thing that you can do. Or what you could do here, you don't need to have a code block as I have here. You can simply remove the bracket and have it like this. This is also a valid implementation of a lambda. So I'm just gonna run this code again. As you can see, we still get the similar behavior that we are looking for. So you can provide as many implementations as you want. So let's say you want to provide another implementation of a lambda. This time around is bank transfer as we had the other time. And then what we can do here, we can say e-wallet implementation. Here you can say bank transfer. And then what you can do here, you can just say bank transfer. So we have two implementations now. And then let's compile this code again and run it. You see we have bank transfer, BSG, Mutusi, e-wallet, BSG, Mutusi. So you see that you didn't require to have more class files, and yet you were still able to give your own implementation. This is what the lambdas are actually giving us. So you can even have a situation whereby you have this. You say public void send. Okay, let me just make send money, and then this is sent. Then in here you just say send dot send so what you want to do is you say send dot send. So here you have to say from and to. So this must be passed here as argument string from string to. So now what you need to do in this case, you can just take your lambda like this, and you remove this, you call send. You pass the lambda expression here, and you remove this one also. You pass the lambda expression, you call. Okay, here it has to be send money. Sorry guys. Then also you must have send money, and you pass it to the lambda. Then this must be static for our code to work. So what we are doing here, we are actually passing functionality to a method. As you can see, this is functionality which we are passing to a method, and a method does something with it. It will do the execution. So let's run this code again. We want to compile it. As you can see, we still get the same result without even declaring things, and then magic is happening under the hood. So what you have to understand is that every a call to a lambda. Implicitly, it's a call to an invoke dynamic. I have a separate article where I explain that. I'll leave it in the description below so that you can read and understand what we just discussed. So this is what a lambda gives you, guys. Thank you.